Euclid also observes galaxies so distant that their light began traveling more than 10 billion years ago. This allows scientists to study the universe's history across time. Early results suggest galaxies formed and clustered faster than expected, and that cosmic structure developed earlier than current models predict. This raises new questions about how gravity and cosmic evolution work on large scales. Another important aspect is cosmic voids, enormous empty regions between galaxy clusters. These voids are shaped by surrounding matter and may be influenced by dark energy, the force driving the expansion of the universe. Early data also hints that dark energy may not be constant, but could change over time. If confirmed, this would significantly alter our understanding of the universe. As data grows, scientists are facing a major challenge. The sheer volume of information is enormous, involving billions of galaxies. Understanding it requires advanced computational systems and machine learning. In many ways, interpreting this data depends on tools that go beyond direct human analysis. Euclid is also revealing gaps in our knowledge. Many familiar regions of space contain hidden structures that were previously undetected. This shows that even well-studied areas of the sky still hold surprises. By combining distance measurements and imaging, Euclid reconstructs how the universe evolved from a nearly uniform early state into the complex structure seen today. Evidence suggests this process may have occurred more rapidly than expected. With only a small fraction of its mission completed, Euclid is already reshaping cosmology. The majority of its survey is still ahead, and future data may lead to further revisions in our understanding of dark matter, dark energy, and gravity. The key takeaway from these observations is that most of the universe is invisible. What we see, stars and galaxies, is only a small part of a much larger structure governed by unseen forces. Galaxies form within dark matter halos, and large-scale cosmic structure determines where they exist and how they evolve. Even empty space is shaped by these forces, stretching and expanding under their influence. Ultimately, Euclid is revealing a universe that is highly structured, interconnected, and far more complex than previously understood. And this is only the beginning of what its full survey will uncover. As Euclid continues its mission, the most important discoveries are no longer just coming from images, but from patterns hidden inside the data itself. Scientists are now using advanced algorithms to analyze the millions of galaxies already mapped. What they are finding is not just structure, but repetition, cosmic patterns that appear across different regions of the universe in ways that were not expected. Some of these patterns suggest that galaxy formation is influenced by deeper rules embedded in the fabric of space itself. It is no longer just gravity shaping the universe, but a combination of gravity, dark matter, and possibly unknown physics working together. One of the most surprising developments is how consistent the cosmic web appears across different time periods. Whether looking billions of years into the past or closer to the present universe, the same filament-like structures keep appearing. This raises a serious question. Did the universe organize itself early and then simply expand, or is structure continuously being rebuilt as it evolves? Euclid is also beginning to detect subtle irregularities in the expansion of space. These are extremely small deviations, but when measured across billions of galaxies, they become significant. If confirmed, they could suggest that the expansion rate of the universe is not uniform everywhere. Another major focus is dark matter distribution. Early maps show that dark matter is not spread smoothly. Instead, it forms dense clusters connected by thin bridges, almost like a web of invisible matter holding everything together. Galaxies are simply forming along these bridges, like lights turning on along hidden cables. Even more intriguing is the possibility that some regions contain far more dark matter than current models predict. These overdense areas could be influencing galaxy motion in ways we do not yet fully understand. There was also an earlier event that became more intriguing over time. Voyager 2 once experienced a brief communication blackout. Its systems shut down unexpectedly, then restarted without external commands. At the time, engineers believed it was due to aging hardware. But later analysis revealed something unusual. Just before the blackout, there was a spike in electromagnetic activity and a sudden change in particle readings. Something had passed through the spacecraft's surroundings, something not directly observed, but clearly recorded in the data. As more information came in, scientists began to reconsider their understanding of deep space. Instead of a simple, uniform region, it now appears that interstellar space may contain layers or zones, each with different properties, each responding in its own way to cosmic forces. This leads to an even more thought-provoking idea. Voyager 2 is not just traveling silently. It is constantly sending signals back to Earth. Every transmission is a marker of its presence, a stream of electromagnetic energy moving through unknown regions of space. Some researchers have wondered whether these signals could interact with their surroundings, not in a science fiction sense, but in a physical one. Could structured regions of space respond to or be influenced by persistent signals passing through them? There is no evidence of intelligence, but there is evidence that the environment itself is more responsive than once believed. And then there is the golden record. Attached to Voyager 2 is a carefully designed message, a collection of sounds, images, and information about humanity. It was intended as a symbolic gesture, a message for any future discoverer. But now, its meaning feels different. If the heliosphere is a defined boundary rather than a gradual transition, then Voyager 2 is not simply drifting away. It is crossing into new regions, carrying that message beyond the limits of the Sun's influence. Despite its age, Voyager 2 continues its journey. It still sends data. It still moves forward. It still reveals pieces of a much larger picture, one that is only beginning to take shape. The question is no longer whether space beyond our solar system is strange. It clearly is. The real question is what that strangeness represents. Is it simply complex physics that we do not yet fully understand? Or does it point to a deeper structure within the universe, one that connects stars, magnetic fields, and regions of space in ways we are only starting to recognize? For now, there are no final answers. Only signals. Only patterns. Only a growing awareness that the universe beyond our sun is not silent, not empty, and not simple. And somewhere in that vast darkness, Voyager 2 continues to move forward, quietly exploring, quietly transmitting, one small piece of the unknown at a time. As Voyager 2 moves farther away, something unusual begins to stand out, not just in what it finds, but in how space itself behaves around it. The deeper it travels, the less predictable its environment becomes. Instruments that were designed to measure simple variations now record patterns that don't fully fit existing models. Energy levels rise and fall in ways that seem organized rather than random. Magnetic fields shift, but not chaotically. Instead, they appear to follow subtle structures, like currents flowing through an invisible ocean. This challenges one of the oldest assumptions in space science, that interstellar space is mostly empty and passive. Instead, it may be something closer to a vast, active medium. Not solid, not alive, but far from still. Some researchers have begun to think of it less like a vacuum and more like a field, something that carries energy, reacts to motion, and possibly even stores information in ways we don't yet understand. Voyager 2, without intention, is moving through this field like a probe through an unseen landscape.